Hi everyone, how are you? I'm hoping you guys are doing great, and here we are back again with a bang, and this time we just came up with a NumPy crash course, NumPy video series, I would say. And this is going to be the last series that you need to go through, last video you need to go through to learn NumPy. From starting, like what is NumPy, how it is different from a list, what are the operations that we can perform, how to create an array, and how to reshape it, how to slice it, how to add the values, how to remove the values, how to sort the values, all the things we are going to discuss in this. This is going to be, as I have told you, the most detailed video that we have created on NumPy on Geeksforgeeks portal. So just enjoy the video and learn, and as promised, this is going to be the last video that you need to learn NumPy. So let's enjoy it, and I'll see you on the other side of the lecture. Take care. Bye. Hello everyone, how are you? I'm hoping you guys are doing great. And from this lecture, we are going to start our journey into NumPy. NumPy is nothing but a library. We are going to discuss what is NumPy, how to install it, what are the different functions we are having, why we are not using list and we are using NumPy, what are the more functionalities we are having in NumPy, which we are not having in list. So those are all the things that we are going to do in this series of 8 lectures. So this is going to be the first lecture. So without wasting any time, just jump into it, and I'll see you on the other side of the lecture. So the environment that we are going to use for coding is this one, which is a Google Colab. All you need to do is just go to Google, search for Google Colab, and you will get to know about this Google Colab, which is an environment provided by Google. It is almost same like a Jupyter notebook. So what you need to do, just click on Google Colab, the first link that we are having, collab.resource.google.com, and this is something that you will get, right? And now all you need to do is just click on new notebook. If you are not signed up for it, just click on sign in, and after that you will get the environment, and after that you can see it is loading. Okay, that means it is providing you the resources. So now here you can see you are having this untitled IPNV, which is nothing but the file name, to be more specific. So here you can define the name of the file, which in this case is NumPy, or I would say introduction to NumPy, which is going to be our first lecture of this series. Okay, so now what we are going to do next, here you can see we are having a button of connect. If you click on connect, it will start allocating you the resources, because this is an online environment, this is not on a local system. Okay, so Google is providing you resources, so it is initializing, and after that this is where you can write the code. You can add few code cells. It is same like a Jupyter notebook. Now you can see tick is there, and here you can see it has provided you 12.69 gigs of RAM and 107 gigs of storage, where you can load your data sets and all. So now, because we are going to work on NumPy, so let's see what we are having in NumPy. So first of all, how to install a NumPy. To install a NumPy, all we need to do is this exclamation mark. After that, you need to write PIP for Python Package Manager. Click space, and after that, you need to write install. And here you need to write the name of the file, which is going to be NumPy. That's how easy it is. Make sure to write an exclamation mark in front of it, and by default it is installed. It is already installed on your system on Google Colab. Okay, so once that is installed, what you can do, now here it has shown you the file location as well. That requirement already satisfied, means file is already installed at this particular location. Now what next? How to import the file, because we know it is installed. How to load the file on our program. To load the file, we are going to write import NumPy. That's how easy it is. Import NumPy to import a file or a library on our system or in our environment. Now what you can do, either you can write import NumPy, or if you want to call it with a shorter name so that you do not need to write NumPy again and again, you can also write import NumPy as NP. What this NP denotes this library, to be more specific. We are not going to write NumPy and again and again. We'll just use NP instead of NumPy. right? So let's execute this and see how it is going. Now here you can see a tick is there, that means this cell is also executed. So if I'm writing np and executing it, so here you can see we are having a module which is called as user. At this particular location we are having this module which is numpy, means my numpy is now loaded. So now let's see how we can create an array. What is a list? Means how an array is different from a list. For that purpose I'm creating a list first of all, and in this list I'm adding three elements, 1 2 and 3. So let's execute this, and I'm expecting you know how list work, how data structure works, right? So if I'm executing LST, so this is 1 2 3, which is the thing, nothing but a list. How to check what is the type of it? For that purpose you can write type. Python is a case sensitive language, so make sure to write type in the same manner. You cannot manipulate the case sensitivity. So here you can see the type of this list, this LST variable that we have initialized as list, right? So now what we can do, how to convert this list into an array. To convert this list into an array, we need to call a function named as array. np dot array, bracket open, bracket close, and inside this we can pass the object that we are having, the variable that we are having, that we want to convert into a list, into an array. So here I am passing my lst, which is now the list. Earlier it is the list, but now I want to convert it into a variable named as array. So now if we are executing it and printing this ARR, because we have taken this list, whatever elements I am having in the list, which is 1 2 3, I have converted them into an array. Now this is a type of array because array is written here. Even if we are checking the type of ARR, here you can see it is of type ND array. What is ND array? ND means it is an n dimensional array. It can be 1 2 3 4 and n number of times. That is why it is displaying ND array, and it is of time numpy. Okay, so this is how you can initialize an array. If let's suppose the list is two-dimensional, right? You can even go for that as well. That will display you a two-dimensional array. Simple. So this is what we have discussed about how to convert an array, a list, into an array. Clear? After that we are having how to check, I would say, the dimensions of the array. Now in this case the dimension is one dimension only, because we are having 1 2 3 element in the same dimension. So what I can do, I can write this ARR, which is my array, and I will write and dim, right? And after going through it, what I will get the dimensions of the array. Okay, array dot n int objectives, and dim, and it is displaying you 1 means this is a one-dimensional array because we are having all the elements in one dimension. What if this is a two-dimensional array? Means I am going for something like this. We are having some length and some width, right? We are having length or rows or columns. So this is a two-dimensional array now. And now if we are converting into an array, this is the array that we are having, which is having two dimensions. So now if I'm checking the dimensions of the array, though it is displaying you this is a two-dimensional array. Simple. Now similarly we can also check the shape of the array, means ARR.shape if I'm writing. So here you can see the shape of the array is 3 cross 3. Why 3 cross 3? Because we are having 3 rows, 3 columns. If we are changing the shape into 2 cross 3 or 3 cross 4, you can go for that as well. This is just to tell you what is the shape of the array, right? Next we are having the size of the array. The size of the array, what it will do, it will tell you how many elements are there in an array. Total of 9 elements are there in this array of size 3 cross 3. Very simple. So this is the function which will tell you how many elements are there. After that we can also check the data type of the array, right? ARR.dtype. If we are going for array.d type, okay, we need to remove this. Now it is displaying you this is of int 64, int 64. This is nothing but an integer of 64 base. Now here you can see as well all the values are integer format. So that is why we are getting the data type of the whole array. Which kind of data that we are having in that array? The data is of integer data type. Okay, so after that what we are having, we can also generate some arrays of zeros and ones of any shape of your choice. Now how to generate that? For that purpose, what we can do, let's suppose I am having a function named as zeros, right? So I'm calling that function now np dot zeros. Okay, np dot zeros is a function. Inside that I am having multiple parameters that I can take. First parameter is going to be the shape. What should be the shape of that array? Either it is 3 by 3, 4 by 4, 5 by 5, 10 by 100, or whatever shape of your choice. So I am defining a shape of, let's suppose, 3 comma 5 for this point of time. Means I will create an array of 3 comma 5 where I will have all the zeros. Clear? Here I'm writing zeros and p dot array of shape zeros, and I think that is the only mandatory part that we are having, because all we need to define is just the shape of the array. Now if I'm going for zeros, so here you can see 3 is the height, which are nothing but the number of rows, and 5 are the number of columns that we are having. Okay, so this is how we have created an array of shape 3 comma 5. Similarly, we can also go for 5 comma 3 if you want, and you can see how the shape changes. Now we are having 5 rows, 3 columns. So first element is for the number of rows, second is for the number of columns. Similarly, we can also generate ones, right? If you want to go for it, np dot ones is going to be there, and the main data type that I need to pass is, the main parameter that I need to pass in this function is the shape, and the shape in this case I am writing, let's suppose 6 comma 3. Let's go for it, just print ones, and here you can see 6 rows and 3 columns. This is how you can create an array, and these are the very basic function that we can use in an array. That's pretty much it, and in the next videos we are going to dig deeper into the different things that we are having in array. Different function we are having, like how to generate random numbers, how to arrange the element, how to create a sequence of elements. So those are all the things that we are going to dig deeper into the next video. So yes, that's pretty much it, and I'll see you in the next one. Hello everyone, and in this lecture we are going to discuss about reshaping the arrays. What is the shape of the array? How to reshape it? How to generate random numbers? How to flatten an array? Those are all the things that we are going to discuss in this video. So without wasting any time, just jump into it, and I'll see you on the other side then. So as you can see, we are going to discuss about reshaping the array. For that purpose, I'm using the same environment, which is Google Colab. I have created a new notebook here, and I'm having the resources of that. Now, first thing that I need to do is importing my NumPy as MP, right? Once that is imported, I will call some functions. Like the first function that I would like to tell you is how to generate random numbers, right? Because this is a very important concept in terms of gaming as well, right? So how to generate random number? For that purpose, I am having a function called as np.random np.random bracket open bracket close, and here we are having multiple parameters that I can pass, and I'm going to pass the main parameter, which is going to be the shape, and the shape is going to be like what should be the shape of that particular random number generator array that you want to have. In my case, let's suppose I want to create an array of just 3 cross 3. Let's execute this, and here you can see you are having an array of size 3 cross 3, and all the elements are randomly generated. Even if I am executing this again in a new cell, here you can see these elements are totally randomly generated as well, right? And now the main point that we have now is all the elements that are generated are from a particular range, and that range is from 0 to 1. Minimum element that can have a 0, maximum we can have as 1, and these all the elements are in that particular range only. So let's suppose if you want to make if you are having a function that you want to call randomly at any place, you don't want to call it in any order, you want to call it randomly. So what you can do, you can generate a random number. Okay, like if I'm writing np dot random and not passing anything, we are getting a random number. So what we can do, we can call a function like if this particular function is giving you the value greater than 0.5, right? Then I'll print okay, just run the function. Okay, and else I would say print don't run the function. Let's suppose this is something that we want to do. So don't run the function. This is again randomly generated. The number is randomly generated, and we are checking if the element value is more than 0.5, which is again randomly generated between 0 to 1. So this is how you can generate random numbers, and this is how I would say it is used in a lot of game playing algorithms. Okay, this is how we can generate random numbers. Now after that, we can also discuss about how we can generate some numbers in a particular sequence. To generate some numbers in a particular sequence, we are having two functions, right? First of them is going to be the arrange function, and second of them is line space. So let's discuss how the arrange function works. np dot arrange function I have defined. This is almost like a for loop. Here we need to define the starting condition, ending condition, and the difference. Starting condition, let's suppose if I'm passing here that I want to start from 1. I want to go up to 10, and every time I want to make a distance of 1. So let's execute this, and it is giving you 1, 2, 3, 4, 5, 6, 7, 8, 9. Why till 9? Because this is something that we will not get there. We will go one less than that. If I need to go up to 10, I need to write here 11. Only then I can reach up to 10. Okay. So now here I have written, let's suppose 10. And now if you want to make the distance of 3. So the first element is going to be 1, then 4, then 7. Because after 7, distance of 3 will return you 10. But there I want to get there, right? Because I can go up to 9 only. So this is how I can generate a range. Clear? So now the last function we are having is np dot line space. This is also kind of the same function, but here it will go for the starting till the end with equidistant. Okay, what I mean to say about it. So for that purpose, let's discuss about the same condition. I'm having 1. I want to start from 1, go up to 10, and every time I'm defining the distance. What should be the distance between 1 and 4? 7 and 4, right? Those are going to be 3. Here I need to define how many values I want in between. Let's suppose if I want 10 values in between, execute it. Here you can see I will get 10 values between 1 and 10, and all those values are equidistant from each other. 2 and 1, 1 distance. 3 and 1, 1 unit distance. 4 and 3, 1 unit distance. 5 and 4, 1 unit distance. If I want to go for, let's suppose 1 to 7, and I want 10 values as that. So these values are starting from 1, go up to 10, and all these values are equidistant from each other. Like 1.666 minus 1, I will get 0.666. For distance between these two are also 0.66. These as well. So this is how line space function works. The main difference between them is here I will start the starting condition, ending condition, and here I will define how many values I want within this particular range. Here I will define the starting condition, ending condition, what should be the difference between those values, right? So those totally depends upon where you want to use it. If you want to need arrange function, you can go for that. If you want to go for line space, you can go for that as well. That's totally up to you how you are using it. Once that is done, after that we are having reshape function. We can reshape an array. Like if I am writing arr here, executing it and running my array here. So the shape of the array is nothing but 3 cross 3. Let's do one thing. Let's change the shape into 4 comma 3. Okay, so if I'm going for 4 comma 3, this is going to be the shape, and printing the array, this is my final shape that I am having. 4 rows, 3 columns. What if I want to reshape this array? If I want to reshape this array, I'm having a function named as np.reshape. I can go for that, right? So here I'm writing np.reshape. Okay, I want to reshape my array. This is something I want to decide here. What I want to reshape? I want to reshape my array. What should be the output shape? The output shape is going to be like earlier the shape is 4 comma 3. Let's suppose if I want to convert it into 3 comma 4 shape. Let's execute it. Just write array inside it, and after that if I'm printing my array,
So here you can see the difference. Earlier we are having 4 rows, 3 columns. Now we are having 3 rows, 4 columns. First element is the same, second is the same, third is the same, but fourth element which is here earlier is now here. This element is here. This is how we can reshape it. If I want to reshape it even further to, let's suppose 6 comma 2 and printing the array. So here you can see it has even changed its shape. But the main thing that we need to take into consideration is whenever you are reshaping an array, the initial number of element or initial size of the element should be equal to final size of the element. Size means how many elements are there in a list. Earlier, if we are talking about an array of size 4 comma 3, 4 comma 3 means 4 multiplied by 3, total we are having 12 elements. 3 comma 4 again 12 elements, 6 comma 2 again 12 elements. The number of element or the size of the array should be same in all the condition. Only then you can reshape an array, otherwise you cannot reshape an array. Once reshape is done, we are having another function which is called as flatten. How we can flatten array, and what do you mean by flatten? So arr dot flatten. Okay, this is the original array that we are having. If I want to flat this array, all we need to write is arr dot flatten, execute it, and the array that we are having earlier in 2 dimension is now converted into 1 dimension. Whatever number of dimensions you are having earlier will be converted into a 1 dimensional array. Either it is 3 dimension, 4, 5, 6, any number of dimension we are having earlier will be converted into a 1 dimensional array. That is called as flattening the array. This is how we can flatten the arrays. Okay, so these are the basic function that we are having to play with the shapes, to get the range, to generate random numbers. Okay, and in the upcoming lectures we are going to discuss about few more functions that we are having, which is about indexing, how to perform arithmetic operations on the arrays. Okay, so these are all the things that we are going to discuss in the upcoming videos. So yes, that's pretty much it, and I'll see you in the next one. Take care. Bye. In this video, we are going to start discussing about arithmetic operations on an array. How we can perform arithmetic operations on an array. Multiplying, addition, subtraction, and all the things. And apart from that, we'll also discuss how to find the maximum and minimum elements of an array as well. In row wise, column wise, all the things we are going to discuss. So without wasting any time, just jump into it, and I will see you on the other side. So here you can see I have created one more Jupyter notebook, or I would say Google Colab, which is it is almost same like a Jupyter notebook. Here I am having all the resources with me, and I am importing my NumPy as NP here as well. And inside it, I'm going to call some functions, right? And first of all, I'm creating an array. And in this particular array, I have initialized some elements like 1, 2, 3, 2, 3, 4, 5, 6. These are all the elements that I'm having. I'm converting those elements into an nb.array, right? And after that, I am printing that particular array. So this is the array that I am having. So what if I want to add 1 into all the elements of the array? How I can do it? So first option is going to be take an element, take the first index of the element, after that access the element, and after that add 1. Means add 1 to 1, 2 to 1, 3 to 1, 4 to 1, 5 to 1, and 6 to 1. Right, this is the approach that we are going to use if we are working on a list. But now we are having an array, so we must have some special operation to perform on this as well. So how I can do it? I will just write array plus 1. Simple. Array plus 1 has to be written, and this is the final output that we are having. 2, 3, 4, 5, 6, 7. Means all the elements we are having are now in add up to 1. We added 1 to all the elements in an array. Similarly, we can subtract 1 element from the array as well. I have not updated anything, right? So if I want to subtract anything, so this is what we will get: 0, 1, 2, 3, 4, 5. Similarly, we can multiply few things. After multiplying it by 1, we will get the same element. But let's suppose if I'm multiplying all the element with 5, so I must have 5, 10, 15, 20, 25, and 30. These are all the elements that I will have at the end if I am multiplying them, right? Similarly, what I can do, I can do the subtraction as well. So let's do one thing. Let's make it look better. Addition, subtraction, multiplication. We can also go for division as well. So let's go for division and remainder and see how these things works. Yes, addition works, subtraction works, multiply with 5 will work, because multiply with 5 will give you the same result. Divide by 1 will give you the same results, and if we are dividing it by, let's suppose, 2, then I'm expecting a different result. If I'm dividing them by 2, so this is what I'm getting. Means 0.51 means I'm getting a full division, and I'm getting the result in integer format, in decimal format, right? So these are the different kind of arithmetic operation I can perform on them. At the same time, I can also perform something like this. What is this now? This is nothing but the square form, right? Means whatever element I'm having, like at the first index I'm having 1, so 1 square will be 1, 2 square will be 4, 3 square will be 9, 4 square will be 16, 5 square will be 25, and 6 square will be 36. So these are all the elements that I'm having after getting a square. We can also go for a cube if you want to, and this is the result that we want. So earlier we need to perform take each element from the index, and after that we need to perform the operation, and after that append at the same location. But now we can perform the same thing with just one line of code, right? And how to append the elements, for that purpose we are having the same parameter, like array is equals to array plus 1, right? So let me do one thing. Let me add a cell here. If I'm printing my array, which is the original array, and now I'm writing array is equals to array plus 1 and appending to the array. So now here you can see the original array is now having the element from rather than from 1 to 6, I'm having element from 2 to 7. Okay, now this particular line that we have written here, we can also write it in this particular manner. Array plus is equals to 1. If I'm writing array plus is equals to 1, it is equivalent to writing array is equals to array plus 1, right? So rather than writing this, you can also write this, but make sure that you write plus before equals to. If you are writing equals to plus will also work here, but on the list it will not work. Okay, like if we are writing equals to plus, yes, so it is not working here as well. So array plus equals to 1 will will append 1 into the original array. Okay, that is not something I want. So for that purpose, just write the operator first, after that write equals to. Okay, so now if we are talking about the original array that we are having now, so let's take the array, right? Just write this array. This is the array that we are having. These are the element. Plus equals to 1, printing the array, I am getting this, right? And we can also write multiply equals to 2, which will multiply all the elements of the array by 2. And now if you're printing the array, this is something I will do. 2 multiplied by 2, 4, 3 multiplied by 2, 6, 4 multiplied by 2, 8, 10, 12, 14, and so on. This is how you can perform arithmetic operation on a list on an array without going with just one line of code. Okay, once that is done, what we can do, how to find the maximum element of an array. To find the maximum element of an array, we are having a function called as array.max. Simple, arr.max, and here you need to define nothing. You will get the maximum element of an array, which is nothing but 14 in this particular case. Similarly, we must have a minimum function as well. Let's see if we are having it or not, and we are having it. The minimum element of an array is 4. Okay, and if let's suppose we are having a multi-dimensional array, then what we can do, let's create an array of multi-dimension then. Okay, array is equals to, and here I'm initializing np dot array function. Np dot array I am writing, and np dot array I am writing, and inside that I am writing my element, which is 1, 2, 3, and here I am writing 4, 5, 6, and here I am writing 7, 8, 9. Okay, these are all the elements that I am having in an array. Okay, I need to close this. And now if we're executing it, this is the array that I'm having. Let's print the array, and inside that you can see we are having 3 arrays. Now how to find the maximum element of an array in row and column wise? For that purpose, what we can do, we can use access for that, right? Array dot max, and inside that we are having two options to go for x is equals to 1 and x is equals to 0. If we are going for x is equals to 0, we will get maximum element in column wise. So for that purpose, now if I'm executing it, so here you can see we are getting an element column wise. Like this is first column, this is first column, this is second column, this is third column. In this first column, which is the maximum element 7. In this column, the maximum element is 8. In this column, the maximum element is 9. Right? So if we are writing x is equals to 0, we are getting maximum element column wise. I will write maximum element column wise. Right? Similarly, we can also go for x is equals to 1, and it will give you maximum element row wise. So let's go for it, and here you can see in this particular row the maximum element is 3, in this 6, in this 9. Same case, you can go for something called as minimum. Let's go for it, and in this particular column we are having minimum element 1, in this 1, in this 2, in this 3. Okay, and if I want to go for, I would say row wise, so it is going to be almost the same, 1, 4 and 7, because the minimum element from this is 1, this is 4, and this is 7. This is how we can go for the elements as well. And after that, if you want to go for the last operation that we are having to find the sum of all the elements, we can go for array dot sum, and yes, that's it. And this is the sum of all the elements of our array that we are having, and the sum is going to be 45. You can even go and count all of the elements, it is going to be the same. Right? So that is pretty much it about all the arithmetic operation we can perform on a list, on an array. And after that, we are going to dig deeper into the dot operator, and after that how to sort the element, how to perform arithmetic operation on two arrays at a time, what should be the condition, right? So those are all the things that we are going to discuss in the next video. So yes, that's pretty much it from my side. If you are having some doubt, you can ask us in the chats. Otherwise, I'll see you in the next video. Take care then. In this video, we are going to discuss about how to perform arithmetic operation on two lists or two arrays, right? So let's jump into it without wasting any time. So here you can see we are having arithmetic operation, which is a Google Colab that I have created again. Here I'm connecting to the Google resources so that I will get RAM and ROM where I can write the code. Here I'm importing my NumPy because it is already installed, NumPy as np. Once that is done, I'm going to create two arrays. Okay, I'm creating one array with the name of np.array, and that is going to be a two-dimensional array. I'm writing 1 2 3. Okay, I'm writing 4 5 6, and I'm writing 7 8 8 comma 9. Okay, so this is the array that I have created, which is my array number 1, and similarly I'm also creating an array which is array number 2, and we are going to perform different kind of operations on this array, and for the sake of understanding, I am just changing the shape of the array, or just changing the name of the arrays. Okay, so that you will get to know which array is the one that we are having. So we are having array 1, array 2. So if I'm printing my array 1, this is the first array. If I'm printing my array 2, this is the second array, which is totally inverse of the first array. Now if I want to add two arrays, right, I am talking about adding two arrays. So how I can add it? I can add it by array 1 plus array 2, and we will get the same element. How I'm getting the addition? This will be added to this. 9 plus 1 10, 2 plus 8 will give you 10, 3 plus 7 will give you 10, 6 plus 4 10, 5 5 10, 6 4 10, and all of the combination will give you a 10. Now what if I am having one more array, okay, which is in the array 3, but here I am having a different shape. Okay, so these elements you can see are having shape 3 cross 3, 3 cross 3, but here I'm having 3 cross 4. So what will happen if I'm performing some operations on this as well, right? So let's see if I'm adding array 1 which is having shape 3 cross 3 into an array 3 which is having shape 3 cross 4. So here you can see I'm getting an operation could not be broadcast together with the shape 3 cross 3 comma 3 cross 4 because this array is having a different shape and this array is having a different shape. If both the arrays are having the same shape, only then I can perform these operations on two arrays. Okay, same thing happens for now. If I am performing the operation on the arrays with the same shape, array 1 and 2, it is performing absolutely fine. 2 3 will also not work because array 2 is having a shape 3 cross 3, 4 is this is having 3 cross 4. If we are having a different shape, we cannot perform arithmetic operation on these two arrays. Okay, now the next thing that we are having, can we perform subtraction operation? We cannot perform subtraction operation as well. Can we perform multiplication operation on the array with the different shape? We cannot do it. But what if I'm multiplying them in this particular manner? So if I'm multiplying them in this particular manner, so here you can see the output. The output is 9 16. Why 9 16? Because 1 multiplied by 9 will give you 9. 2 multiplied by 8 will give you 16. 7 multiplied by 3 will give you 21. This is the basic multiplication operation that we have performed on this. Now the next thing is, what if we are performing the operation which is multiply operation in dot product? Because we have understood, we have learned the concept of dot products on matrix, how to perform dot products on matrix. For that purpose, what we can do, I am printing my array 1 first of all and array 2, and after that we are going to perform dot operation on both these arrays. How we can perform dot operator? I will write ARR1 dot because that is going to be dot operator. Here I need to define array number 2. Okay, this is the dot operation that we'll get at the end. How dot operator works? So what we will do, we'll multiply this with this with this, plus this with this, plus this with this. Let's see if it is working perfectly or not. Means I am multiplying my 1 with 9, 1 multiplied by 9. Okay, this is the formula which I am explaining to you for the dot product. 1 multiplied by 9 plus 2 multiplied by 6, 2 multiplied by 6 plus 3 multiplied by 3 plus 3 multiplied by 3, which will give you 30, and I am getting 30 here as well. That means multiply this with this plus this with this plus this with this will give you 30. And same operation we are going to perform in all the elements, and this is the dot product that I will get at the end. Okay, similarly you can check it that if the dot product of 1 with 2 and 2 with 1 is going to be the same or not. Okay, 1 with 2 and 2 with 1 are going to be different, they are not going to be the same, right? But you can check them somehow that these values are somehow manipulated. Means array 1, here I am having at the top left I am having 30, here at the bottom right I am having 30, here I am having 84 at this position, here it is at the exact reverse position. This is here, this is here. Okay, so the values are going to be same, but they are in reshaped or they are in manipulated format. Okay, this is how we can perform arithmetic operation on two arrays, and also the dot product, how we can perform dot products on the same as well. Now the next very important thing that we are having is about indexing, how indexing works on an array. Okay, so let's suppose this is the array that I'm having. Okay, this is having some height and some width as well. So let's create a simple array, right? dot array where I am having just few elements like 1 2 3 4 5. Okay, so you know how to access the element of a list. Similarly, we can also access the element of an array, right? If I'm printing array, I'll get all the elements. If I'm printing this, I will get all the invalid syntax. Okay, if I'm writing colon in between, I'm getting all the elements of the first index, okay, or of the first dimension, because this is a one dimension array. How to access the first three element? I can write here 0 colon 3 will give you first three elements, 0 colon 2 will give you first two elements, 2 colon none will give you all the elements except the first two elements, right? 1 2 is not given, all the elements are there. How to get all the elements are after expecting the first two and last two elements? This is something that we can do. First two is removed, last two are removed, I am getting last three elements. How to getting all the elements except the last two? This is what I can do. So this is how the indexing works. This is how we can access the element from an array using indexing. This is just an example of 1D array. Let's see how we can work on 2D arrays. If I'm performing the operation on this 2D array, what I can do? So here I'm going to use two columns. Okay, I need to write array 1 here, otherwise it will throw me an error, because array 1 is going to be 2 dimensional and basic array is in 1 dimension. So this is returning you all the elements. If I want to take, let's suppose, what if I'm performing this operation, what I will get? I will get all the elements. This is going to be used, one of them is going to be used for the rows, second one of them is used for the columns. Let's see how this works. If I'm writing 1 here you can see we are getting all the rows but only the first column. Okay, means this is used for the columns, this is used for the rows. Okay, now that is clear. Means if I want to take only the first row, what I can do? Row, because for dealing with rows, this is what I need to use. Dealing with rows, this is what I need to use. Because I want to just take the first row, I need to write here 1, none comma 1, which will give you the first row. Okay, all the elements of the first row you will get 1 2 3, which is I am having now. How to get all the elements of first two rows? I will write here 2. It will return you all the elements of the first two rows. Okay, what if I am performing like all the elements of first column? Because here I want to deal with the first column, I am going to write here 1, none comma 1 will give you all the elements of the first column, which is 1 4 7. All the elements of the second column, only the second column, I need to write here 2. If I'm writing here 2, I will get all the elements of first two columns, but I want only the second column. For that purpose, I will write 1 colon 2, which will give you this center part. Okay, this particular column I am having. So this is something we have discussed, how to select a particular column and particular row. But how we can select some particular cells with respect to rows and column. Let's suppose if I want to take the middle element, this one. So this is the element which is from the second row and second column. Second row, second column means this will give you second row, this will give you second column. Execute it and you are getting a 5. This is exactly how indexing works, how you can crop a particular portion of the whole array. Like if you want to take only this particular portion, what we can do, like here we are going to use, let's see if we are performing this. We are getting 5 6 8 9 because we are getting all the rows except the first row, right? We are removing this part and we are removing this part, first row and first column we are removing, and remaining we are having 5 6 8 9, which is the exactly cropped array we are having. So this is how we can perform different kind of operations on multiple arrays. How we can perform arithmetic operation on two arrays, the shape should be same. Okay, and how we can work on the dot operator, we can work on dot operator as well. The shape is going to be same here as well. And here if we are talking about the slicing, how to slice an element, how to access some elements from a particular array of a particular index, we are going to use slicing for that, and this is how slicing works. If we are having one dimension, only one column should be there. If we are using two-dimensional list, two columns should be there. Similarly, for 3 and 4 dimension, we need to use those many number of columns. Okay, first them used for rows, second them used for column. That's pretty much it. If you're still having a doubt, we are having the comment section for you. Otherwise, I'll see you in the next lecture with the new programs. Take care then. Bye.
From this lecture, we are going to discuss about sorting, different kind of algorithms, and how we can perform sorting using NumPy array. Right? We are going to discuss about different sorting techniques like quick sort, heap sort, merge sort, time sort. Okay, which is going to be which are going to have different kind of complexity like n square, n log n, or whatever they are having. So that is not the part of this particular session, that how these algorithm works, but we are going to discuss how to perform these algorithms on nothing but a particular using NumPy array on a list. So for that purpose, I have created one more Google Colab. So let's import NumPy as NP really quickly, and let's create an array this time. Multi-dimensional array we are going to create, np.array, and in this particular array I'm going to now writing the elements in shuffled order. Okay, so I'm writing 5 elements here and 5 elements here and 5 elements here. Okay, so let's make this whole array of 2 dimensions, and let's save it into an element named as ARR, which is nothing but the array. So let's display it, and this is something that we are getting now, an array of size 3 by 5. Okay, now what is going to be the approach now? We are going to sort this array in different kind of formats. Okay, so let's see how we can sort this array. To sort this array, we are having a function named as np.sort. Okay, so how to perform the sort function? So let's write np.sort first of all, and after that let's see what are the different operations that we are having in NumPy sort. So from here you can read the documentation. This plays a very important role. First of all, what I can define A, which is nothing but the array which I want to sort. After that I can apply access. Okay, access is nothing but like if I want to I would say sort them in row wise or column wise. Okay, and after that I am having, okay, after that we are also having kind. Kind is nothing but means which kind of algorithm you want to apply. Like here you can see we are having quick sort, merge sort, heap sort, stable sort. Okay, and after that we are also having something called as order, string or list of optional when a list is an array with the field defined. Okay, so that is something that we can neglect for this particular time, but you can go through the documentation to know more about it, because I am just going to tell you which are the most important things that we are having in NumPy array. So here the first element is obviously going to be the array that we are having. Array is ARR, and after that I am defining the access. Access I am defining to 1. Okay, 1 is used to sort the array row wise. Okay, and after that 0 is for column wise. So let's see if that works or not. After that we are having the kind, which kind of algorithm we want to apply here. So I am applying merge sort for this particular time, and see how the merge sort works. Merge sort is having a complexity, worst case complexity I would say, of n log n. Okay, so let's perform that now. Okay, so let's execute this and let's see what we are getting. So after performing merge sort, this is something that we are getting. What is this? So these are all the elements in sorted order. Sorted order row wise, because access is 1, so we are sorting them row wise. So earlier you can see the elements are 7, 3, 8, 6, 4. These are the elements which are earlier, but now the elements are 3, 4, 6, 7, 8. Sorted order 7, 2, 9, 8, 6 earlier. Now 2, 6, 7, 8, 9 sorted. Earlier 5, 4, 2, 3, 1. Now 1, 2, 3, 4, 5 sorted. So this is how we can sort the elements row wise. So let's see how we can sort the element column wise as well. For that purpose, access is going to be 0, kind is going to be the merge sort only, because we are performing merge sort. Okay, so let's execute this, and here you can see now all the elements are sorted
column wise. So the first column earlier is 3 to 1. Now it is 5 7 7 because the elements are in the same order only. Okay, this is my original array earlier, 7 5 5. I'm performing on this. So earlier 7 7 5, now 5 7 7, because 5 as the top, 7 7 are going to be the same, so we are going to sort them accordingly whatever we are writing. Earlier it is 3 2 4, now it is 2 3 4. 8 9 2 2 8 9, 6 8 3 3 6 8, 4 6 1 1 4 6. So this is how we have sorted them using merge sort. If you want to sort them using different algorithm, you can go for that as well. Means if you are going for quick sort, which is having a worst case complexity of n square, you can go for that as well. But comparatively, in most of the cases, heap, merge and tim sort works better as compared to quick sort, because it is having less worst case complexity. Okay, so that's up to you which algorithm you are using. But basically what we have discussed how to apply merge sort on an algorithm. Okay, what else we are having? Okay, we have discussed about all things, like if we are not defining axis, what will happen, let's discuss that as well. Okay, so this is the NP array. Let's suppose if I have not defined axis, what will happen? Let's execute this. And from here you can see, if you have not defined any axis, then what will happen? It will sort them in row wise. If it will sort them row wise, if you have not defined anything. If you are defining anything, that will depend upon you if you want to go for row wise or column wise. If you just want to go for row wise, you do not need to define any axis as well. All you need to define is just an algorithm which you want to apply on your array. So that's pretty much it. Let's summarize whatever we have discussed so far. So what we have done, we have first of all created a NumPy array. After creating that NumPy array, we have displayed it. We have discussed how to apply the sorting algorithms on it. For that purpose, we have used merge sort after with the axis 1. Axis 1 works when we want to sort the element row wise. Even if you are not writing anything, axis is going to be 1. Now, what if I want to sort the elements column wise? For that purpose, we are using the same thing, which is np.sort array axis equals to 0 kind merge sort, which is going to be the same. And at the end, we are sorting the element without anything, and it will sort row wise. So that's pretty much it about this particular video. If you are having any doubt about sorting the things, you can ask us in the discussion. If you want to dig deeper into how merge sort, quick sort, heap sort, all these sorting algorithm work, we're having another channel. You can go for that. You can search about Geek for that. So you will get to know about all the algorithms for that. Okay, so that's pretty much it. If you guys are still having any doubt on this, you can ask us in the discussion or comment box. Otherwise, I'll see you in the next lecture with the new programs. Take care then. Bye. Hello everyone, and from this lecture we are going to discuss about arrays. Nothing but not just about arrays, but we are going to discuss how we can perform slicing or cropping or indexing in arrays. We have discussed about it earlier as well, but today in this lecture we are going to dig really deeper into it and see the basic fundamentals of it. So let's jump into it without wasting any time, and I will see you as always on the other side for the summarization. So now here you can see I have created an array 5 with the name 5 dot, which is this is lecture 5 of NumPy array. So array slicing is the name. Let's connect the resources on Google Colab so that we can start writing the code, and Google Colab can provide us the resources for it. So I'm creating a NumPy array, right? And here let's create a NumPy array, np.array. And here I'm going to create a multi-dimensional list. 1 2 3 4 is there. After that I'm writing 5 6 7 8, and here I'm writing 8 7 6 5 4 3 2 1. Okay, this is something that I have created. Let's close this and let's end this, and let's save this into an array. So this is the array that we are having. Okay, and let's see how we can access some element from this particular array. So to access some of the elements, first of all, what we can do, we can take a smaller array, one dimensional, because this is a two-dimensional array. Okay, so first of all, what we are going to do, we are going to discuss about what we can do on one-dimensional array. Once we are done with one-dimensional array, after that we will discuss about multi-dimensional array. So in this particular array that I have created, this is a one-dimensional array. So how to access some elements from this particular array? For that purpose, we are going to use indexing. Indexing is same process as we are using in NumPy in lists. So what we can do, we can go for array of 0 and we will get the first index of that particular element, which is nothing but 1. Similarly, if we are going for array of 1, we will get 2. Similarly, for 3, we will get 4. For 2, we will get 3 because it is starting from 0. This is 0th index, element at 0th index is 1. This is first index, element at first index is 2. This is second index, element at second index is 3. Similarly, 7th index, element at 7th index is 8. Okay, so this is how you can access the element from a particular array and list as well. Now, how to access a particular area or particular number of elements from a list? For that purpose, what we can define, this is just a one-dimensional list. So I write one column here. Make sure it is not a semicolon, it is a column. Okay. Here I am having two conditions and both of the condition are boundary. First of them starting boundary, second of them is ending boundary. So if I'm not writing anything, it will display all the elements that we are having so far. 1 to 8, all the elements are displayed. If I'm defining any boundary range from the starting, if I'm writing, let's suppose 3, it will remove first 3 elements and display all the elements. Because here I have not defined any ending condition, that means all the elements are displayed after this boundary condition of starting. It will remove first 3 elements from the starting and display all the elements till the end. Okay. Similarly, how to access all the elements of the array except the last 3 elements. Except last 3 means all the elements I want to take from the beginning. From the last I want to take last 3 elements I want to remove. -3 should be written here. Last 3 elements are removed, 6, 7, 8, and we are getting the elements. Okay, how to remove first 3 and last 3 elements? For that purpose, what we can do, we can go for the same array boundary condition. In the beginning I need to write 3, at the end I need to write -3. So all the elements in between, after removing first 3 and last 3, we are having 4 and 5 remaining. Clear? So this is how indexing works here, okay, in the one-dimensional list. And how we can perform the same on two-dimensional list. So to two-dimensional array. To work on two-dimensional array, we are having the same approach here. But here the process is going to be quite different because earlier I am having one dimension, now I am having 2 dimension. To deal with 2 dimension, I need to have 2 columns with a separator. Okay. So this is the boundary condition for rows. This is the boundary condition for columns. Let's discuss about row first. So these are the rows that we are having 4 rows. If I am writing nothing and executing it, I am getting too many indexes. Okay, let's go for this point of time. Okay, these are all the okay. I need to execute this first, and after that I am going for this because earlier I am using this particular array because the name of this array is the same. Now if I'm executing it, it is taking all the arrays with all the rows and all the columns. Now what is going to be the next step? The next step is going to be how to access a particular elements or a particular area, or for this particular time a particular row. This is used for row, this is used for column. To access the first row, what we are going to write, I'm going to write none comma 1, right? This will return you the first row. Let's execute this and check. This is returning you the first row only. What if I want to access the first 2 rows? Just write none colon 2 and it will return you the first 2 rows. What if I want to access the first only all the rows after the first row, but not the first row? So you can run it and you will get all the rows except the first row. You're getting 5, 6, 7, 8, 8, 7, 6, 5, 4, 3, 2, 1. Okay. So what if you want to access just the second of them? Can we go for something like this? Yes, we can go for something like this as well. 2 means at index 2. This whole list is at index 1, this is at index 0, this is at index 1, this is at index 2. At index 2, I am having this whole row. Okay. Now, if I'm talking about a particular column, because now we know how to deal with the rows. I'm taking all the rows except the first row. Now how to deal with columns, that is something that we are going to discuss now. How to deal with columns? To deal with columns, we are having an approach which is going to be here, right? Here I need to define the starting condition and the ending condition. Starting condition is nothing but 1 and ending condition is nothing but all. So if we are executing this, we are getting all the columns except the first column. Simple. So all the column except the first column will return me the same thing. So if I am writing, let's suppose 1 colon 2 and execute it. So here you can see we are getting 6 7 3 6 6 7 3. This is something that I am getting. Why I am getting this? Because 1 colon and we return me all the rows except the first row. Means this is something, this I will get this and I will get this. Here I have selected the first index, means from 1 colon 2, means this is at 1 up to 2, means I will select this one because this is the boundary condition. I will not reach there. If I am having a distance of 1, I will take this particular element, means the first index. It is something like this, okay? Because at index 1 I want to display, either I can write 1 or I can write 1 colon 2. That's totally up to you. So what we have used, I have used the first row and first column. If I am displaying this, so what I'm getting means at this is 0th index, this is first index, this is second, this is third. This is if I'm talking about row wise, this is 0th index, first index, second index, third index. So at 1 1 I'm having 6. Okay. At let's suppose 2 2, what I'm having a 6 again. This one. What I'm having at 2 3. At 2 3, okay, I need to write 3 here. So at 2 3, what I'm having at 2 3, I'm having a 5. Okay. Why I'm having a 5? Because at index 0 1 2 3, 0 1 2, this is the 5 that I'm having, right? Row wise it is at 2nd index, 0th index, first index, second index, row wise, and third index column wise, 0 1 2 3. This is the 5 that I'm having. If I'm going for 3 cross 3, that should be this particular 1. Okay. Similarly, for 3 colon 1, that is going to be a 3. Which 3? That is going to be this one. Okay, 0 1 2 3 0 1. This is going to be the thing. So this is how you can access the element. Now let's go for the last part, which is going to be the cropping. How to crop the elements. To crop that, the process is going to be the same. Let's suppose you want to crop this particular area from 6 7 8 7 6 5 3 2 1. How to crop this? I want to remove the first row and first column. Remove the first row, 1 colon all. 1 colon none means removing the first row. 1 colon none means removing all the columns except the first, or removing the first column. Okay, so this is what I am getting. 6 7 8 7 6 5 3 2 1, which is this particular area that I am having. 6 7 8 7 6 5 3 2 1. So this is all about indexing or slicing or cropping a particular NumPy array. If you are still having it out, we are having the discussion session or comment works for you. Otherwise, I'll see you in the next lecture with the new program. Stay care. Bye. Hello everyone, and from this lecture we are going to discuss about HV stack, means how to concatenate different NumPy arrays, either row wise or column wise or in any dimension we want to add it, how we can add it. So without wasting any time, just jump into the lecture and I will see you on the other side. So as you can see, this is the notebook that we have created with the name as array merging. Right, we are having some arrays that we are going to merge. For that purpose, let's quickly import NumPy as in P, and let's start writing the code, or let's start initializing few arrays. So I'm initializing array 1 and I'm writing np.array, and here I'm initializing a 2-dimensional array. Okay, 1 2 3 4 is the first elements, and after that I'm creating 5 6 7 and 8. These are the first these are the 8 elements that I have created for the first 1-dimensional list, and I am also creating array number 2 with the same case. Okay, I'm writing the reverse of it, 8 7 6 5, and here I'm writing 4 3 2 1. Okay, so here I have created two arrays and both of them are giving you an array, and problem or error because I have made a mistake in the names. So if I'm writing arr dot arr of 1, which is nothing but the array 1, so this is what we are getting: 1 2 3 4 5 6 7 8. This is the shape of the array. After that, if I am talking about array 2, so this is the shape of the array, or this is the array 2 as well. Now what we are going to do, we are going to concatenate them either horizontally or vertically, okay, or we can either concatenate directly as well. So now let's see how to concatenate them. To concatenate them, we are having few functions called as hstack and vstack. Okay, let's discuss about first of all vstack to concatenate both of them vertically. For that purpose, I am having a function named as vstack. np dot vstack. Okay, here I am having few parameters, but I am going to just pass two parameters like what I want to stack. I want to stack my array 1 with array 2. Okay, make sure to write them in the same order. So if I are executing it, so here you can see what we are getting: 1 2 3 4 5 6 7 8 is written here till here, which is my first array. After that, from 8 to 1, we are having second array, means we have stacked both of them vertically. First array 1 is on the top, array 2 is at the bottom. Now what if I want to make array 2 at the top, 1 at the bottom? Just reverse this process, 2 and 1, and boom, you are getting the elements in the opposite order. So this is how you can stack them vertically. Now you might think how to we know how to stack them vertically. Now just tell me how to stack them horizontally. For that purpose, we are having h stack. Okay, and now you can see both of them are stacked horizontally, right? 1 2 3 4 5 6 7 8, 1 2 3 4 till here, and 5 6 7 8 till here. After that, we are having 8 7 6 5, which is here from 8 7 6 5 to 4 3 2 1, from here to here. This is how we can h stack, we can perform h stack, which is horizontally stack. Okay, what if we want to do the reverse of it? To do the reverse of it, the process is going to be really simple: 2 and 1 and run, and this is what you will get. Okay, 8 7 6 5 4 3 2 1, and at the end 1 2 3 4 5 6 7 8. This is how to concatenate them or stack both of them in the same order. Now you can also use some other function like concatenation, or which is something that we'll use for concatenating the string. The performance or the work is going to be the same, but here you can use indexing. Okay, so let's start working on that particular part as well. np dot concatenate is going to be the function. Okay, concatenate function is something that we are going to use here. Here you can see we can apply basically two functions, like basically two parameters. First of them is going to be what I want to concatenate. I want to concatenate obviously going to be strings in the tuple format, means in brackets, and the second is going to be the access. So let's perform. First of all, I want to write array 1 and array 2, right? And second is going to be the access. Now if the access is 0, right, if the access is 0, then we are going to perform horizontal stack or vertical stack. For 0 axis, we are going to perform vertical stack. For 1 axis, we are going to perform horizontal stack. You will get to know about this from the documentation as well, right? So they must have given you about the axis, like axis, like it is written here: axis which is array belongs to join. If axis is none, array is flattened before the used. By default it is 0. Okay, so by default the axis is 0. So if I am performing 0 here, so here you can see array is not defined. Okay, I need to define arr2 because we are having nothing as array. This is either array 1 or array 2. So you can see if the axis is 0, they are vertically stacked. If the axis is 1, they are stacked horizontally. Yes, so this is how you can concatenate them. Now the question might be, now we know how to concatenate the string, but just tell me how to split the strings or split the arrays. Like if we are having an array, okay, let's do one thing. let's take this array which is ERR. I am writing ERR here. Okay, so if I'm writing this array, so this is the array that we are having. They are having 4 rows, 4 columns. Now just tell me how to split them. To split them, we are again having a function to split. We can split them horizontally as well as vertically. This is just a reverse process of VStack and SStack. We are having, for VStack we are having VSplit, for SStack we are having SSplit. Very, very simple. So let's go for it now. So what we are going to do, we are going to use np dot hsplit. Split is the function that we are going to use. Here we are having only the parameter what I want to split. I want to split my original array which is ERR. I want to split it in 2 halves, let's suppose, horizontally. So if I'm executing it, what I'm getting 1 2 5 6 8 7 4 3. Means from here till here we are having one element, I would say first dimension, and here you can see from here to here to means okay 3 4 7 8 6 5 2 1. 3 4 7 8 6 5 2 1. This is means we are having an array of shape 4 by 4 that we have reshaped into 4 by 2 and 4 by 2, 2 4 by 2s. Okay, similarly what we can do, if you want to do it, we can also split it vertically. Okay, and you can see the difference now. 1 2 3 4 5 6 7 is at the first index. Like here you can see bracket open bracket close, and here bracket open bracket close here. So you can split them horizontally as well as vertically. That totally depends upon you what you want to do it with it. Clear? So yes, these are all the operations that we can perform on NumPy array for stacking and splitting. So just to summarize the session, we have created 2 arrays, array 1 and array 2, with the shape 2 cross 4, 2 rows, 4 columns. Okay, and yes, after that what we have done, we have applied VStack, means vertical stack we have applied, and we have merged them into 2 by 4 into 4 by 1 4 by 4. Means from 2 by 4 into 1 4 by 4. Okay, after that what we have done, we have performed stack on it, which will make a 2 by 8. Okay, after that we have also performed them the reverse of it, how to means how to take array 2 first and after that array 1. After that we have used concatenation operation rather than stack and vstack, how we can use concatenation operation for the same. After performing it, what we have done, about h split and b split, which is just a reverse of s stack and v stack. So that's pretty much it about this particular video. If you guys are having any doubt, you can ask us in the discussion or chat box, or so-called, I would say, comment box. So yes, that's pretty much it. If you guys are having doubt, you can ask us. Otherwise, I'll see you in the next lecture with the new programs. Take care then. Bye. From this lecture, we are going to discuss about how to automate, about the automation to be more specific, using NumPy. Right. So I am going to take an example, and after that we'll see how to solve the example using basic logic, and at the end we'll discuss how to solve the same example but with NumPy's and build function. Okay, so let's jump into it. So here you can see I've created a new notebook, and inside that I'm importing my NumPy. Okay, I'm importing NumPy as NP, and after that what I'm going to do, I am going to create a list for this point of time. And what I'm going to do, I'm defining some of the numbers here. Okay, 6 7 8 9 and 10. These are the numbers that I have defined. Now what I'm going to do next, I'm going to make a program that will tell me how many elements are there in a list which are more than 5. How many elements are there which are more than 5. For that purpose, what should be the basic step that I need to follow if I'm not using NumPy array? So the step is going to be, I'll go for I in list, means I'll go for each and every element from the list, and I'll check if that particular element is greater than 5. I'll count that particular variable. I'm deletionizing a counter with 0. Every time I found the value more than 5, I'll increase that particular counter, and at the end I am printing that particular counter. And here you can see there are 5 values, 1, 2, 3, 4, 5 values which are more than 5, which is 6, 7, 8, 9, 10. This is the basic process that we are following earlier, right? But what if we want to do this in just NumPy arrays? So let's see what is the process to do the same with NumPy array. So what I'm going to do, I am taking this particular list, but I'm converting this into a NumPy array this time, np.array. I'm taking the same named as LST. So if I'm printing LST, this is the array that I'm having. So what I'm going to do now, I'm going to write something like this. Okay, colon. Okay, this is the process. Like what we are going to do, we are going to make a equation which will means we are going to define the equation in just particular line, in just one line. Okay, so how we are going to do it? Like if I'm writing LST greater than 50 or greater than 5 and execute it. So here you can see it is returning me few things. And what are those things? Those things are true and false. The shape of the array is going to be the same. Like here I am having 10 elements and here I am having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements here as well. Now what is the difference? The difference is going to be like in the first 5 elements are false. Next 5 elements are true. That means wherever the value is more than 5, those values are true. Wherever values are less than 5, those are false. Clear? So this is a very simple process, how we can automate the process using NumPy. Okay, and how to find all those elements. Earlier, how we can find the element, what we are going to do, rather than printing the counter, we are going to print that element as well. So these are going to be the element which are more than 5. Right, 6, 7, 8, 9, 10 and 5 is printed at the end, which is this cube, means total 5 elements are there. But if I'm talking about this process, what I can do, all I need to write is LST bracket open bracket close, execute it, and you will get all the elements which are more than 5. That's how easy it is, because what this is doing, this will tell you which are true, which are false. And if I'm passing this through the original list, what it will do, wherever in whichever index we are having true, we will print that value. Wherever I am having false, I will not print those values. So this is the basic approach. Means whatever we are doing here, same thing we can do here as well, to find all the elements which are more than 5. Now you might think how to find the length of all the elements, means how many elements are there. This is displaying you all the elements, but how many elements are these? So for that purpose, what I can do, I can write len in front of it and execute it, and we will get to know about the length of them as well. We are having total 5 elements which are more than 5, and those elements are something called as 5, 6, 7, 8, 9. Right, so this is something that you can do. Like I am printing those elements, and after that I am printing that particular list as well. So we are having total 5 elements, and those elements are 5, 6, 7, 8, 9, 10. Earlier I need to write the logic by our own, but here I just need to define one line. Define in one line if we are working on NumPy arrays. And this is how easy it is. And this is why we are using NumPy arrays instead of using list, because they are much faster than list as well. Now we are having one more question, like if I want to know how many elements are there which are fully divisible by let's take 3. So to check about it, all we need to do is just change the condition. Fully divisible by 3 means which will give me a remainder of 0. Means if I'm dividing all those values by 3, they should give me a remainder of 0. Right? If they are giving me a remainder of 0, that means they are divisible by it. Otherwise, they are not divisible by it. So let's go for it and check what is the output. And here you can see 369 are the number of 369 are the elements which are fully divisible by 3. And earlier what we need to do, we need to take each and every element, check if that is divisible by it or not. If it is divisible, I need to print one thing. If it is not divisible, I need to print another thing. So this is the very basic process that we can follow here. Okay, so element divisibility is something that we can use here. And similarly, we can also, let's suppose if you are having a NumPy array with the names. Okay,
we are having some grocery item, or we are having, let's suppose, some let's suppose marks, or anything we are having in terms of categories or in terms of strings. So what we can do, we can use this thing. We can use very simple approach which will return me at which particular index I am having that particular name or that particular value, right? If that particular value is there, it will print true, otherwise it will print false. And if we are defining it within this particular range, which is nothing but the original list, it will return you all the indexing or all the rows where you are having that particular value true. So this is pretty much it about how to automate the things or using basic processing in NumPy, right? And this is very powerful as well. As compared to lists, they are much faster, means they are multiple times faster as compared to lists. So that is why they are using more often. So yes, this is pretty much it. If you are having any doubt so far, you can ask us in the discussion or comment box. Otherwise, I'll see you in the next lecture. So let's summarize whatever we have done so far. So whatever we have done, we have just created a list. After that, we have made a logic using for loop. We are checking how many elements are there which are more than 5. We also find the frequency of it. Once we have found those frequency and elements, after that what we are doing, we are using the same process, but now we are using a NumPy array instead of using a list. Once that is used, after that what we are going to do, we are going to use a very simple one-line approach to do the same thing using NumPy. So that's how easy it is. So yes, that's pretty much it, and I'll see you in the next one. Take care then. Bye. So I'm hoping you have enjoyed the session overall, but whatever we have done so far using NumPy arrays. Okay, we have initialized it. First of all, we have worked on that. We have initialized it, we have gone through it, we have reshaped it, we have sliced it, we have concatenated it, we've sorted them based on rows and columns. All of the things that we have done so far, I'm hoping you have gone through it and you are having all the resources with you. If you want to get the codes are also there in the description. You can go to the description and get all the code that we have done so far in the whole crash course. Okay, and if you're still having any doubt, do let us know in the chats. We are more than happy to solve your queries, and we are going to arrange more such session for you on different modules. Either it is OpenCV and means data analysis. So these are the things going to be there. So make sure to be a part of it. If you like the video, make sure to like it, subscribe the channel, leave us a comment, whatever you feel, either it is good or bad. Feedback is a feedback. Make sure to give a feedback, and I'll see you in some other course. Take care. Bye.